Welcome back. In the last lesson, we looked at the role of 7 QC tools in problem solving and studied the first QC tool, histogram. Now let's continue to the second QC tool, that is check sheets. Check sheets are simple and effective tool primarily for collecting data. The check sheet can be used to record many types of functions like process variation, number of defects, defect location, startup checks, and many more. Since check sheets are meant to be referred to at a later stage, they should have elements like who, what, when, where, how much. But at the same time, the point is to make this data easy to obtain and use. So we have to be very careful about the formats of the check sheets. An ideal check sheet is easy to fill and captures all the required data adequately. A check sheet for defective item count may look something like this, where all the defects are listed in one column, and then we have check mark against the respective column as the defect appears. So what if a defective part has two defects? In that case, mark a check against each of them, and then in order to have an account of the total defective parts, you can have a different row at the bottom. So the upper part of this format will give you the total number of defects, and the last row will give you the total number of defective parts. As you have guessed already, the sum total of defects may not be equal to the number of defective parts. Similarly, a defect cause check sheet will look something like this, where we mark different symbols for different defects, and the data captured with this check sheet can help us understand the relation between the cause and the effect. Like you can easily see that worker B is producing the most of the defects. Also, on Wednesday, all workers had numerous defects. And there are no defective finish part on machine 1. So this way, a check sheet can also guide us as to where we should concentrate on. Another great example of a check sheet for process variation is frequency table, where we have tolerance range on the x-axis, and then based on the actual measurement of the product, we mark a check in the respective column. And we do this for 100% of the parts. And in this way, we can make a histogram in real time. There are many types of check sheets available, and the purpose of all the check sheets is to collect data. The point to remember is data reflects facts, and when our analysis and decisions depend on data, we must make sure that the data is authentic, because no matter how accurate our analysis is, the result will be meaningless if the data is incorrect. Let's move to the next tool. Pareto charts are used to identify the most significant issues that need to be addressed first. In simple words, it helps us to prioritize our tasks. It is named after Vilfredo Pareto, an Italian economist who invented the 80-20 principle that states 80% of the effects comes from 20% of the causes. Here is how to create a Pareto chart. First, identify the problem or issue that we want to analyze and the factors that can cause this problem. Then, collect data on these factors, and yes, you can use cause-effect checklist or other methods to gather the data. Count the number of occurrences of each factor and put them against the factors. Now, sort the factors in descending order of frequency, and in step 4, calculate the cumulative frequency of each factor in the adjacent column. And then, calculate the cumulative percentage of each factor by dividing its cumulative frequency by the total count of factors and then multiplying by 100. Once this data is ready, draw a bar graph with the factors on the x-axis and the frequency or count on the y-axis. Using the secondary y-axis, draw a line graph on the same chart for the cumulative percentage. Connect the starting point to the top of the first column. And that's it. A Pareto chart will help you identify vital few factors that account for the most significant proportion of the total effect. So, for the time being, we can focus our efforts here and neglect the trivial many. In case your Pareto chart look more or less flat, then you should stratify your data and arrange it into different groups and make Pareto again. For example, while working on the process defects, you can also stratify your data operator-wise, day-wise, or time-wise until you see a good Pareto. That way you will be able to identify whether you should focus on a particular defect operator, or at any environmental condition to get the maximum results with minimum efforts. Let's move to the next one, control charts. It is an excellent tool to study the behavior of a process over a period of time and to predict if the process is going to be out of specification. It is a big topic, and I have already made a series on statistical process control and the control charts. Here is the link if you wish to study control charts in detail, and if you already know the control charts, you can click here and skip to the remaining QC tools. Make your choice. I will see you there.